begins to move under the action of the time dependent force. What is the force vector here given? Force vector equal to 2t I cap plus 3t square j cap Newton. Listen. And here what is the mass value given? Mass value is 1 kg. We need to find the power value. So what is the power formula? Power formula is
V. F dot V.
very good. Power formula is F dot V. Okay, so what is a V? So we need to find the value V. So V equal to integration of A into D. Then how do you get this A? How do you get this A?
F equal to
Yes, A we can write like this. A equal to F by M. Okay, so now you see what is the F vector? That is 2ti plus 3t square by j, 3t square j by 1. Again you will get the same here acceleration equal to F by M. So where F value is 2ti plus 3t square j by M. Again you will get the same value here. Yes or no? So 2ti plus 3t square j by 1. Anything by 1 is you will get the same value here 2ti plus 3t square j. So this is the form. This is the acceleration vector. Then to get the velocity, what you have to do now? Velocity equal to integration of acceleration into change in time. Okay. So what is acceleration we have here? Acceleration equal to 2ti plus 3t square j into dt. Okay, integration of x power n into dx is x power n plus 1 by n plus 1. So integration of 2t into dt is how much here? Integration of 2t into dt is 2t square by 2 I 3t square. Okay, to integrate the t square into dt, what is the formula? Integration of t square into dt is t power 2 plus 1 by 2 plus 1. That is how much? T power 2 plus 1 is 3. T power 3 by 3. Okay, so where 2 get cancelled here, 3 get cancelled. So answer is t square I plus t cube j. This is a velocity vector, right? Okay. So now to get the power, so what is the formula to get the power? Power equal to force into velocity. So I am writing here. So what is power? Power equal to force into velocity. Force vector dot velocity vector. What is the force vector we have here? That is t square I plus t cube j. So this is the velocity vector. Sorry, this is the velocity vector. What is the force vector? What is the force vector?
2ti square
2ti
cap plus 3t square j cap.
Okay. You do the dot product. Dot product means I dot I value is 1, j dot j also 1. Okay. So look at here everyone please. 2t square into t square how much? 2t into t square is how much? T into t square is t power?
2.
No.
3.
Already this power 2 is there, here power 1 is there. 2 plus 1 is how much?
3
cube. T cube I. Plus 3t square into t cube. How much it is?
3 power 5 j cap.
T power 5 j cap. So the answer here, which one is matching here?
Option B.
Yes, option B is matching. A particle moves from a point minus 2i plus 5j to 4j plus 3k. When a force of 4i plus 3j Newton is applied, how much work has been done by that force? So to find this, we have a formula: work equal to force into displacement. You have to find the delta R. Then how do you find the delta R? To find the delta R, we have a formula R2 vector minus R1 vector. Let us say this is R1 and this is R2. What is R2 vector we have here? 4j plus 3k. There is no I term. So let us assume that is 0i plus 4j plus 3k minus R1 vector is how much? Minus 2i plus 5j. So there is no k term. You write here 0k. Now you see, so there is a I term. So you just differentiate by I to I. So your 0 is there. Minus into minus will become plus. So 0 plus 2i. Next here we have 4 and here we have 5. So 4 minus 5. 4 minus 5g plus here we have the 3 and here we have 0. So in between minus is there. So this we can write 3 minus 0k. So 0 plus 2 is 2i. 4 minus 5 is minus 1. So this we can write as minus j plus 3 minus 0 is 3k. So this is the position vector. Now you find the work. Okay. So work formula is force vector dot displacement vector. So what is the force vector we have? 4i plus 3j dot position vector is 2i minus j plus 3k. Okay. So while multiplying these vectors, you multiply. This is the dot product. I dot I value is 1. Okay. So now you multiply this. 4 into 2 is how much? 4 into 2 is 8. 3j minus j. 3j minus j is 3 into minus 1 is minus 3. Then 8 minus 3 is 5. Is there any k term here? No, there is no k term. Let us say this is 0k. So 0 into 3 is 0, right? So this is 0. So 8 minus 3 is how much? 5 joules. So work equal to how much here? 5 joules. Is it clear, everyone? Okay, so your answer C is matched. A uniform force of 3I plus j Newton acts on a particle of mass 2 kg. Hence, the particle is displaced from the position 2I plus k meter to the position 4I plus 3j minus k meter. Because of the force, the particle is moving from the position R1 to R2. Then how will you find the change in position? Delta R equal to R2 vector minus R1 vector. We have to find the work done by the force. R2 minus R1. So where R2 value is 4I plus 3j minus k. 4I plus 3j minus k minus. What is the R1 vector we have here? 2I plus k. Now you see 4I minus 2I, how much? That is 2I. 4I minus 2I is 2I. 3j minus 0. So there is no j term, so you write as 3j only. Okay, so what is the k term we have here? Minus k minus of minus k.
Minus 2k.
That is equal to minus 2k. Okay, so minus k minus of minus k is minus 2k. So this is the value of delta R. Then how do you find the W? W equal to
F dot.
force vector into displacement vector. Okay. So delta R. What is the force vector? Yes, Vaishnav, please note that. 3I plus j dot 2I plus 3j minus 2k. Okay. So now while multiplying, you multiply with I dot I. So 3 into 2 is how much? 3 2 ja 6. So here j term is 1. Here j term is 3. 3 into 1 is 3. So here we have the minus 2. Yes. So there is no k term, right? So let us say this is 0. So 0 into minus 2 is, yes, that is minus 0. So 6 plus 3 is how much? 9. So your answer 9 joule is matching. So option C is matching. Is it clear, everyone?
Yes, sir.